Hey, so it's the time to take up the solution for the next question. So here we have this question which talks about plane mirrors. Let's read the question for more clarification. This says two plane mirrors M1 and M2 have their reflecting faces inclined at theta. So let's have a look at the figure. So here we have this figure in which two plane mirrors M1 and M2 are inclined at angle theta. Further, the question says mirror M1 receives a ray AB, reflects it at B and send it as BC. So AB is the incident ray on mirror M1 and this BC is the reflected ray. Further, the question says it is now reflected by mirror M2, which you can clearly see here in the figure, along CD. So mirror M2 is reflecting this incident ray BC, which was the reflected ray for mirror M1, and reflected ray for mirror M2 is CD. Okay. This question demands we need to find out the total angular deviation delta suffered by the incident ray AB. Now this was the incident ray and this is the reflected ray. So what is the angle of deviation? That is this. Okay. Here in this figure you can clearly see here we are given delta 1 and delta 2, which are the deviation produced by mirror M1 and M2 separately. We know what is the deviation produced by the plane mirror, that is 180 minus twice of angle of incidence. So here if I just mark the normal for this mirror as well as for this mirror, and if I say that angle of incidence is alpha here, what is going to be the angle of reflection? Come on. That is going to be the equal to the angle of incidence as per the laws of reflection. And if I mark here the angle of incidence for this mirror is beta, this reflection or angle of reflection is again going to be beta. So this delta 1 will simply be 180 minus 2 alpha and this delta 2 will simply be 180 minus 2 beta. Now what is this net deviation going to be? That will be simply the sum of delta 1 plus delta 2. So that will be 360 minus twice of alpha plus beta. Now here if you have a look at the options, you need to find out this delta in terms of this theta. Now here you can clearly see if this angle is alpha, as this is the normal. So what is going to be this angle? That will be 90 minus alpha. If this is beta, what is going to be this angle? That will be 90 minus beta. And if you just apply the angle sum property of triangle here in this triangle BOC, I can simply write from this triangle that this theta plus 90 minus alpha plus 90 minus beta is equal to 180. Why I am writing this? From the angle sum property of this triangle. Okay, and this will give me theta as alpha plus beta. So I can simply substitute here alpha plus beta as theta. So this delta will come out to be 360 minus 2 theta. So you can clearly have a look here at the options. So which option is the correct option? That is option D. I can put it into the separate box. I can also write here that correct answer for this question is option D. I hope this question is very clear to you. Now let's quickly move on to the solution for the next question. Hey, so here we have this next question, that is question number 4. This says in the adjacent figure, line AB is parallel to screen S. A linear obstacle PQ between the two is also parallel to both AB, PQ and screen S are coplanar. A point source is carried from A to B along the line AB. What will happen to the size of the shadow of PQ cast due to the point source on the screen? So here you can see this is the arrangement. This is line AB, this is PQ and this is the screen. Now as per this question, a point source is taken from A to B. We need to see that what is going to happen with the shadow of this PQ on the screen. Now to solve this question, here you can see, let us suppose here we have taken the point source somewhere here and this is how its shadow is going to form. This is angle theta. Let us suppose this distance is L1 and this is L2. And if I just take this, that is the length or the height of this as h, Now here you can see there is a formation of this triangle and this triangle, and these two triangles are similar. So if I just go by the similarity of triangle, I can similarly write here that tan theta is h by L1, and here in this triangle, and for this triangle I can write down that if I just consider this to be h dash, I can write down tan theta will be h dash divided by L1 plus L2. On comparing these two, I can write down h dash as h in the bracket L1 plus L2 divided by L1. So this is this h dash that we have calculated here. Now here you can see, let us suppose this point source now has moved to this point. Now if I just take this distance to be L1 and this to be L2, and as you can see this is in the middle, so we have taken this complete to be h in the previous case. Now this will be h by 2, and let us suppose we just write here this as y. So in this case we need to find out this y. This angle is again going to be theta. So here again if I write down tan theta for this triangle, that will be simply be h by 2 L1, and for this bigger triangle I can write down what is going to be tan theta, that will be y divided by L1 plus L2. Now on comparing these two, I can simply write down y as h in the bracket L1 plus L2 divided by 2 L1. Now here you can see the shadow is going to be twice of that of y. So if I just take the shadow length or the length of the shadow to be y dash, that will simply be twice of y, and that can be written as y dash as h in the bracket L1 plus L2 divided by L1, and this is same as that of the above case. So here you can see in this case also this shadow length h dash comes out to be the same. This is what we are getting in the second case also. So if you have a look at the options, so here you can see that option C is the correct option, which says it will be of the same size for any position of the point source on the line AB. So I can mark this to be the correct option. Let's put it into the separate box also, and let's write here also that the answer of this question is option C. I hope this question is very clear to you. Now let's quickly move on to the solution for the next question. Hey, so it's the turn to discuss the solution for the next question, that is question number 5. This says two particles P1 and P2 move towards the origin along x and y axis at constant speeds u1 and u2. As shown in the figure, at t is equal to 0, the particle P1 and P2 are at distances a and b respectively from O. So here this is the origin and this is particle P1. Let us suppose the particle P1 is here and particle P2 is here, that is at a distance a from the origin, and particle P2 is at a distance b from the origin at time t is equal to 0. Now as per this question, particle P1 is moving with uniform speed u1 and particle P2 is moving with uniform speed u2. Now let us suppose after time t, the particle is here, that is particle P1 is here. So what is going to be this distance? That will be u1t, and particle P2 is here. What is going to be this distance? That will be u2t. Now as per this question, we need to find out the instantaneous distance s between the two particles. Okay. So what is the instantaneous distance between the two particles? That is this distance. So simply if I just write this distance to be s, this can be calculated if we just see that what is going to be this distance. See here, this distance is simply, what is this? This complete distance is a and this is u1 into t. So this will be a minus u1t. And what is this distance? This distance is b minus u2 t. So, we can calculate this s by using the Pythagoras theorem here, and s will simply be equal to the square root of this distance, that is a minus u1 t whole square plus b minus u2 t whole square. So, if you just calculate this, you will get option A as the correct option. So, correct answer for this question is option A. I hope this question is also very clear to you. Now, let us quickly move on to the solution for the next question.